Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again. This is Teacher Pasco, and today I will be with the senior 2 students. Going ahead with unit number 6, the preparation of salts and identification of ions. In the previous lessons, if you remember, we discussed the solubility, how we perform various calculations involved in solubility, and we also saw how temperature affects solubility. So, if you remember, we've seen that as temperature increases, we get more and more solubility for a given salt or for salts. And have you imagined what we can get if we use those data to make graphs? Different data as we are changing temperature, and the different data as the solubility is increasing. What we can get from that is something we call solubility curves. Solubility curves. You know the curves, the graphs, you know them in mathematics, in physics you have used them so many times. And today we are going to use them in chemistry. Before we start today's lesson, let us have a look at the objectives of our lesson. At the end of this lesson, you should be able to read and interpret solubility curves. I give you a solubility curve. You should be able to explain the information you are reading from it. You should be able to explain why it is like that. And you will use the graph to determine the solubility of a substance at a given temperature. So if the solubility curve can give different values of solubility values at different temperatures, then from the curve, from the graph, you can determine the approximate solubility of a given substance at a given temperature. Let us start. What is a solubility curve? It is a graph, but a graph which shows that what? A solubility curve is a graph showing the relationship between temperature and solubility of the substance at different temperatures. So we have different values of solubility at various temperatures. So if we have a value of X and a value of Y, then we can combine them to find a point. And if we join all the points we get from the data we have, then we can get a graph. So the graph we get is the one we call solubility curve. And by definition, we can say it is a graph which shows the relationship between temperature. Relationship means how will temperature affect the solubility. And it is the relationship between temperature and solubility of the substance at different temperatures. How do we proceed when we are drawing a solubility curve? To draw a solubility curve, temperature is represented along the x-axis. This is the x-axis on our curve, on our diagram, the graph. This is the x-axis, so we put temperature here. And the solubility will be put along the y-axis. This is the y-axis. From 0 upward and from 0 onward, to higher values. So various solubility points plotted are connected by a smooth curve, which is the solubility curve. If, for example, we consider the point here, let us say here we have 5 and here we have 2. What does it mean? It means that the solubility here at this temperature is 2. So we always connect 2 points, a point from Y and a point from X. At a given temperature, there is a specific solubility value. At another temperature, a higher temperature, you can see that we will have a higher solubility. So the solubility is increasing as temperature increases. That is the reason why we have a curve which looks like this. So we always connect 2 values to get a point, and after getting enough points, you can also connect them to get a curve we call a solubility curve. Here we have an example. Solubility of copper sulfate at different temperatures. This is the temperature in Celsius degrees, and here we have the solubility. Remember, solubility is the amount of solute in 100 grams of a solvent. And here we are talking about water. So the solubility we have here will be calculated value from the grams of solute dissolved in 100 grams of water at this temperature, the temperature we have here. At 0 Celsius degrees, we have 14. At 10, it's 17, 20, it's 21. At 30 degrees, it is 24. 40 degrees, it is 29. And 50 degrees, it is 34. What do you realize when you look at the values we have here? As temperature increases from 0 up to 50, solubility is also increasing. So if we combine these 2 points, remember, temperature will be on the y-axis and solubility will be on the, temperature will be on the x-axis and solubility on the y-axis. It's clear. And then we get, for example, a value of 0.14 somewhere here. Here there is a mistake, but it should be somewhere here. When we have a temperature of 0, then the value will be somewhere here, to 14. When we have 10, it will be something like 17. So the value will go increasing, or the solubility curve will also increase. If you take something like a temperature of 35, which is between these two, 35 is here, then you can find the solubility, which will extend. You will use a line extending from this point up to here. So that is how we construct a solubility curve. You always find points, but the points which are having 2 coordinates, a y-coordinate and x-coordinate, and when you combine the 2 values, x and y, you get a point. The point you get, when they are enough, you can then join them to get your solubility curve. And what do we get from the interpretation of the solubility curves? After studying, analyzing solubility curves, what do we get? Here is a list of all the information we can get from interpreting solubility curves. After studying the solubility curve, the following information can be obtained. First one, the solubility of a substance at a particular temperature can be determined. As I've shown you on the previous slide, if, for example, you don't know the solubility at 70, you can determine it from the solubility curve. Clear? If you consider this 70, as it increases, you go higher in the values of y, then you get what? You can get the value of y, corresponding to what? Corresponding to this temperature of 70. So from the solubility curves, we can determine what? We can determine the solubility of a substance at a particular temperature. Secondly, we can also determine the solubility of a given substance at any temperature. So if you have a solubility curve, you can determine the solubility at any temperature. Any temperature, you can extrapolate. You can use the values you have on the graph, but just know that you can determine the solubility at any temperature of a given substance. And number 3, the solubility curve will help us predict which substance will crystallize out first from a solution containing 2 or more solutes. Remember, substances have different solubilities. If you have a mixture of solutes in a solution, the 2 components or a given number of components, they cannot precipitate out if you cool down the solution, for example. And why is it like that? It is because they have different solubilities. So the one which has a lower solubility at a given temperature will precipitate out first. So like that, you can do what? You can separate the components of your mixture. Remember, if substances have different solubilities, then in the time of crystallization or precipitation from solution, you will find that the substances will precipitate at different temperatures because they have different solubilities. And because of that, we can use the solubility curves to predict or to determine which substance will precipitate first, the one which has a lower solubility. Number 4, the solubility curve will help us to compare the solubilities of different substances at the same temperature. If we have 2 substances like potassium chloride and potassium nitrate, let us consider the 2 substances at a temperature of 50. At this temperature of 50, if we draw a vertical line, which is perpendicular to the x-axis, what do we get? We will find a point somewhere here. But if we go up, we find another point. And from this point, if we find the value, the corresponding value of y, we can determine the solubility of potassium chloride at 50 degrees. You can see that it will be somewhere here, below 80. But if we do the same with potassium nitrate, it will be somewhere here, above 80. And it shows what? It shows that we can use solubility curves to compare the solubilities of different substances at the same temperature. As you can see, at 50 degrees, if you consider the solubility of potassium chloride and that of potassium nitrate, you can see that that of potassium nitrate is higher than that of potassium chloride. So we can also use solubility curves to compare solubilities of different substances at the same temperature. And another thing we can get from the interpretation of solubility curves is that it brings the change in the composition of a solute substance. And finally, it gives a clear idea that solubility of substances change with the temperature. from what we have, the data we have here, you can see that as temperature increases, the solubility is also increasing. But even if you don't consider the values, the table of data, you can also consider the curve. The curve is increasing, going up, going up, going up. You can see that as temperature increases, the values of solubility are also increasing. So the solubility curves can give us a clear evidence that temperature really affects the solubility of solids. Now let us go on with the exercises of interpreting data from the solubility curves. This is another example of solubility curves we have used. And here we have some questions we are going to try. This is the graph with different solubility curves we will be using to answer these questions. It's a worked example, and we will answer the questions we have here using the solubility graph we have. Question number 1. How much sodium nitrate will dissolve at 30 degrees? How much sodium nitrate will dissolve at 30 degrees? I will do this one for you, just as an example. The temperature we have here is 30 degrees. 30 degrees is here. We have 20, so this is 10, 5, and here it is 15, 25, 30, at 30 degrees. But on the graph, we have so many curves. So we don't use any, because there is a particular substance the question is considering. And the particular substance the question is considering is sodium nitrate. The curve which is representing the solubility of sodium nitrate, this is the sodium nitrate compound, it is this one in green color. Now, let us find the solubility of this sodium nitrate at a temperature of 30 degrees. What do? You draw a vertical line. As I said, you will make sure that it is perpendicular to the x-axis. And it will go up like this, up to this point. You make sure that it touches the curve. The curve, it will be touched here, from this point. And from the same point, then you extend another line up to the solubility axis. You make sure that the extending this line, which is extending from the solubility curve up to the solubilities on the y-axis, is also perpendicular to the one joining temperature axis and the solubility curve. So this one should be perpendicular to the x-axis, and this one here should be perpendicular to the one which will be vertical. So it should be like this. If you have your curve, which is like this, and then here we have y-axis, this is x-axis, and here we have y. Then at temperature x, if you want to know the value, you draw a line joining the solubility curve and the x-axis, temperature axis, and then you make sure it is perpendicular. And then you draw another one extending from the solubility curve up to the solubility values, the solubility axis, that is for Y, and then at this temperature, you find the value solubility. So the value you will have on this axis will be the solubility of this substance at this temperature. That is how we do it. Now, let us check on the answer we have here. What is the answer? At 30 degrees, as I've shown, the 30 degrees are here. And we draw the perpendicular line up to this point. We also draw another one up to the solubility axis, the y-axis. And you can see that it is approximately 95. So at 30 degrees, 95 grams of sodium nitrate will dissolve in water to make a saturated solution. Let us go to the next question. Which solid is most soluble at 60 degrees? What do we have to do here? We consider the temperature. At 60 degrees, we are here. And then you consider the value, the curve, which has the highest value of Y. Because we have the same value of X, temperature. So you can see that the one which has the highest value of Y at this temperature is sodium nitrate. So the solid which is most soluble at this temperature is sodium nitrate. Another example, which one is the least soluble at the same temperature? Think about it. Which one? At 60 degrees, we have determined the one which is most soluble. Which one will be the least soluble? Think about it, please. Yeah, it will be the one which has the lowest value. So it is sodium chloride. And the third question, which solid is least soluble at 40 degrees? Try the third question. You determine the substance or the solute which is least soluble at 40 degrees. It's here. Very simple. So it is the same as what we've just done. So it is sodium chloride. Sodium chloride. If we go to the fourth question, at what temperature will 60 grams of sodium sulfate dissolve in 100 grams of water? Sodium sulfate is this one, the orange curve. At what temperature? 60 grams. So we look at the y-axis. 60 grams, they are here. So if we extend the line, we find that it is here. And what is the value? What is the temperature? It is 50, 40, 45, and 50. So at 50, we will have 60 grams of sodium sulfate dissolved in 100 grams of water. Number 5, the temperature of a saturated solution of sodium nitrate, the same compound, is increased from 60 to 80 degrees. So it's from 60 here to 80 degrees. You can see that as temperature changes, even the solubilities change. And the question is asking what mass should be added to the solution to make it saturated again. So we check on the difference in the solubilities. At 80 degrees, the solubility is 140. And at 60 degrees, the solubility is 120. And the difference is 20 degrees. So if you increase temperature from 60 up to 80, you will need to add more 20 grams to make the solution saturated again. It is how you can do even if you want to find the mass which will precipitate out when you decrease temperature. But in that case, you will move from a higher temperature to a lower temperature. For example, if you move from 80 up to 60, then 20 will precipitate out. I think it is very clear. And as I'm very sure that it is very clear, let me give you an exercise. The homework. Which of these substances is most soluble in water at 15 degrees? You will use the graph we have here. And just like how we did it, you will determine the substance which is most soluble at 15 degrees. Number 2, what is the solubility of potassium nitrate at 70 degrees? Potassium nitrate, where is it? It's here. You determine the temperature and you find its solubility at that temperature. At 90 degrees, you dissolve 10 grams of potassium chloride in 100 grams of water. Is this solution saturated? From the graph, you can determine whether it is saturated or not. And here you will have to explain your reasoning. And the last question, a mass of 80 grams of potassium nitrate is dissolved in 100 grams of water at this temperature, 50 degrees. The solution is then heated to 70 degrees. How many more grams of potassium nitrate must be added to make the solution saturated? And you explain your reasoning. This is the same as the last question we did for the worked example. Everything is clear, very easy to understand, and I'm very sure you will make it well. And let me thank you very much for your attention, for always being there for these classes. And I want to tell you that if you need further reading, you can visit the e-learning portal of Rwanda Education Board. Thank you very much. See you next time for the next lesson.